correspond with the PWM output or input that we give it, and then output a different level of intensity for our for our propeller thrusters. So which allows them to operate at negative 100% to 100% thrust, giving us forwards and backwards movability. And based on the combination that our program is set to, we can also create a turn by moving backwards with one thruster and forwards with another, giving us very many different types of behavior depending on how we program and how we control the thrusters. Now, as I mentioned before, we have a pressure sensor in the back, which is an analog input, and this pressure sensor reads the pressure and then has been modified to give an analog input or output to this FRC controller. This FRC controller then goes up and sends a message to the tether, which responds to our operator board and gives us the two numbers that I mentioned before, which represent the pressure of the pressure reading from our system. Now we also have two different relay outputs, which correspond with the two different Bilströms seen here. The relays allow us to move forwards, neutral, or backwards with the two Bilströms seen here, and can control the motion of our claw as well as our winch operator. And aside from our FRC controller, we also have the Arduino Mega. The Arduino Mega is a custom chip that we bought, and basically what it allows us to do is it controls the three different underwater servos that we have here. Two for the rotating camera and one for the opening and closing of the claw. The Arduino Mega processes the commands that we send via the computer through the Xbox controller, and then responds to those commands by positioning the different servos at a different angle based on the numbers that we give it, and then ultimately allows it to pan up and down, and as well as open and close our claw. The Arduino Mega was programmed with the open source wiring language, which is used by the Arduino board, which is pretty similar to the C programming language. And the FRC was programmed using a MPLAB editor, as well as using the C18 compiler. And we custom created the code for the FRC by modifying the code that came on it and adding our own parts. And the Arduino was fully customly programmed by ourselves. We created version code for it, and we uploaded onto it, and fully programmed by us. And the way the Arduino interfaces with our computer is through another program, which is linked to our GUI, and that is programmed in C#, which is also a custom program, and it is used to interface with the Arduino via a serial interface, which was also programmed inside. So that's how the computer relays communications to our Arduino, which finally controls all the motors and all the interfaces, allow our robot to operate efficiently. And this was all created by us, and based off of just the coding language, I guess.
Okay, so our sensors. First we have the camera sensors. As pilots of the robot, half of the problem is to send the information down to the robot, while the other half is receiving information back from the
Nick Selby, and I'm an incoming senior.
I'm Ryan Berger. I'm an incoming sophomore.
Chelsea Rainbow, I'm a baby.
Hi, I'm Kevin Zay. I'm also incoming senior.
I'm Shergill Walker. I just graduated this May.
I'm Peter Truer, and I will be a senior.
Are there other members of your team that didn't make it? It seems like they're-
There are a few. We had some last minute sick cases that were, I think, at least one of them was stress related.
Oh, no.
Yeah.
Sorry, how long did it take you to go?
We've been working on it for such a long time. I mean, it's been like almost a year. We've been recycling parts from our old robot that we had from last competition, which gave us kind of a head start, Like this winch mover here, this was actually taken off our old bot because we had a similar mission. So that was taken off our old bot, and everything else, however, was custom made, like the new cranial cavity. We had to weld that together. It took us a total of maybe like 9 to 10 months to create the whole thing, but yeah, we've been working on it since maybe like October, September.
What are you using the winch for?
This year we're using the wincher to actually operate the winch that they have us, turn.
The data block.
Last year it was the bait activator.
Yes.
Oh.
I have a question for the two of you guys are pilots, right? You switched.
Myself and Kevin.
Actually, us two are pilots, yes.
How, I was wondering, do you have a special technique you use for depth perception when you guys are actually practicing? Do you have something special?
We actually have a panning camera, so we use that to pan down, we move it up and down, and based on the response that we get, we can kind of feel how deep we are. Because these two cameras are pretty much stationary, we have to depend on this one to get the depth, actually. So we look up and down, and then based on that, we turn a bit, and then try to see like where the angles are at the pool. And that gives us a very, very good like idea of where we are. And based on because if we turn this down, we can obviously like see the crease, right? And that shows us how we are, and then we move it around left and right, and then see if there's any other creases to tell us where we are.
Can you turn the vehicle so we can see the rear end of the winch?
Okay.
Oh, actually,
The other end.
Oh, yeah, front.
do a little prices around.
Right here.
So, have you guys thought about the priorities for the mission, or are you just trying to do everything?
We will obviously try to do everything if time allows, but our main priorities will be the fuel rod, because obviously we lose points if we do not complete that, the radioactive fuel rod. The winch will be a big one, alien capturing will be a big one, and locating and saving the trapped / disabled AUV will be our main priorities.
It's like a mission plan like this, check this in.
Yes, we actually have a packet of paper that we have with us on site on board that has the list of our mission objectives and how we're going to solve.
Well, we have an advantage here